Bismillahirrahmanirrahim and Assalamu alaikum. I am Dr. Saima Rashid and today I am giving the lecture on the topic of reflex action. Learning outcome. At the end of lecture, students should be able to define reflex action. State the components of reflex are. Distinguish between sensory and motor components of reflex action. Classify reflexes based on time of appearance, physiology, and clinical practice. Describe the properties of reflex action. A reflex may be defined as an immediate involuntary response to a stimulus. A reflex is a fast response to a change in the body's internal or external environment in an attempt to restore homeostasis. Reflex action is defined as any response that occurs involuntarily or automatically without conscious effort. It is the mode of action of nervous system. There are two types of reflexes: simple or basic reflexes, which are built in, unlearned response, such as pulling the head away from a burning hot object; acquired or conditioned reflex, which are as a result of practice or learning, such as driving a car or typing. Stimulus exist in many energy form: light, sound, pressure, taste, and chemical changes. Receptors are highly sensitive to one particular stimulus modality, that is, each receptor is specialized to respond to one type of stimulus, which is adequate stimulus. For example, receptors in the retina of eye are sensitive to light rays, in the ear to sound waves, and heat receptors in skin to hot and cold temperature. Receptors convert stimulus energy into receptor potential, which in turn converted to action potential. Reflexes and diagnosis. Evaluation of a reflex can aid in doctor in diagnosing a problem. A reflex which stops functioning or functions abnormally may indicate that a particular central or peripheral conduction pathway in the body has been damaged. The reflex action. The nerve pathway involved in a reflex action, including at its simplest a sensory nerve, a motor nerve with a synapse in between. Reflex arc. The neural pathway involved in a complete reflex activity is known as reflex arc, which includes five basic components. Sensory receptors sense the change in the environment or stimulus. Afferent sensory pathway, integrating center, spinal cord or brain. Efferent motor pathway, effector organ obeys the command and performs the action. Sensory and motor components of a reflex. Reflex arc consists of an afferent or sensory part and an efferent or motor part. Afferent part include stimulus receptor and sensory neuron. Stimulus. It is a detectable physical or chemical change in the environment of the receptor, for example, touch, pain, light, and sound. In response to stimulus, the sensory receptor produces a receptor potential, which in turn triggers an action potential or signal. The signal is relayed by the efferent pathway to the integrating center, which may be spinal or brain, for processing and coordination. Motor components of a reflex. Motor components include integrating center, efferent or motor neuron, efferent pathway to the effector organs. The spinal cord and brain stem integrate basic reflexes, whereas higher brain centers usually process acquired reflexes. The integrating center makes a decision about appropriate response and sends a command via efferent pathway to the effector that carries out the desired response. The effector organ that obeys a command is skeletal muscle in somatic nervous system, cardiac or smooth muscle, or a gland in autonomic nervous system. Example of a reflex action. Stimulus. Heat from a flame receptor present on the skin senses hot temperature and produces receptor potential that is converted into action potentials or signal. Sensory nerve fiber carries the signal enter the spinal cord through the dorsal root. Signals ascend up the lower brain and finally reach the sensory cortex, which receive signal, process them, and give command. Command is sent via motor neuron to muscles of hand to perform action, that is, remove itself from the hot source. Classification of reflex: physiological, clinical, and time of appearance. First is the monosynaptic. It is superficial type of reflex and it is can be inborn or unconditioned. Disynaptic, that is deep, and the third one is the polysynaptic, that is the visceral or pathological, that is acquired or conditioned. Now, physiological classification. It depends on number of synapses involved in a reflex arc. Monosynaptic involving one synapse between sensory and motor neuron, thus very rapid response, that is stretch reflex. Disynaptic involving two synapses, that is Golgi tendon organ reflex. Polysynaptic, more than two synapses involved in a reflex arc, withdrawal reflex. Clinical classification. The classification is used by the clinician depending upon the location of receptors. Superficial receptors located in skin or mucous membranes, such as touch, pain, pressure receptors. Example of reflex include corneal, conjunctival, abdominal, plantar reflex. Deep receptors located in the deep structures, such as muscle spindle and Golgi tendon organ in muscle tendons, for example, the reflex, stretch reflex, or the tendon reflex. Visceral receptors are located in the wall of the viscera, such as baroreceptor, pressure receptor, chemoreceptor, glucoreceptors, and each include deglutition reflex, micturition reflex. Pathological, not present in normal persons, Babinski sign and clonus. Difference between basic and acquired reflexes. Basic or unconditioned reflex, acquired or conditioned reflex. Inborn reflexes present since birth, acquired later in life by the practice, fixed in number. Number can increase or decrease. Spinal cord is required, cerebral cortex is required for conditioning. Always persist in life, may be lost with time. For example, withdrawal reflex, knee jerk, deglutition reflex, and cuff reflex. For example, driving a car, typing, playing piano. Properties of reflex action. Adequate stimulus. Stimulus of threshold level is required to elicit a reflex action. Central delay. It is due to time required to pass through a synapse. Minimum time delay is zero point 0.5 millisecond. Properties continued. It can be of two types: spatial summation and the temporal summation. Spatial summation, if a sensory neuron is stimulated in two neighboring areas simultaneously, a response is summated, and this is called the spatial summation. Temporal summation, if a sensory nerve is stimulated with the same strength of stimuli successively, a response is obtained, and this is called the temporal summation. Response is summated. Properties continued. Fatigue. If a reflex arc is continuously stimulated, response goes on decreasing and ultimately stops due to fatigue. First seat of fatigue is synapse. Reciprocal innervation. If a sensory nerve is stimulated, muscles on the same side will be stimulated and antagonist muscles will be inhibited. Rebound phenomena. If a response of a particular reflex is inhibited for some and then suddenly released, stronger than normal response would be obtained. The seventh one is the habituation and sensitization. If a response is not important, it goes on decreasing, called habituation. Decrease in synaptic connection between sensory and motor neuron. If a noxious stimulus is accompanied with a reflex, response continues for a long time. Sensitization strengthening occurs. Occlusion. If we stimulate the branch A with maximal stimulus, all nine neurons will give response, and if we stimulate branch B with maximal stimulus, all nine neurons will give response. But if we stimulate both branches A and B simultaneously with the same strength of stimulus, we get response of 12 neurons and not 18, and reason is central. 6 neurons are common to both branches. Properties. After discharge, if a stimulation is stopped abruptly, response continues for some time and delay fades away. This is called after discharge, and it is due to continued discharge of motor neurons by impulses arriving from the reverberating circuit